It's always a great pleasure when I'm able to introduce an international speaker that I've worked with on other things. Ondrej Filip from NIC.CZ, sorry, has been good enough to come to UKNOF. I think it's the first time you've been to UKNOF meeting?
Yeah, it's my first time here.
So welcome.
Thank you.
Ondrej's going to be talking about an open router platform that they've been working on.
Yeah, and actually I will talk also a little bit about security, so it was a very good introduction this afternoon. So hello everybody, and thanks again to the organizers for inviting me here. It's really great pleasure to see you all here. My name is Ondrej Filip, coming from Czech Republic and working from a company called CZ.NIC, which is CZ.NIC, which is actually domain operator for .CZ, which probably sounds quite strange, right? Those registries are usually not very active in fields like routing, routers, and stuff like that. But we are a little bit strange. We are a little bit different. We started a company and started to register domain, and then it happened that we had some surplus of money, and we were really thinking what we are going to do with this money. We can either travel to more meetings like at the registries or doing some other crazy stuff, or we can spend those money on something we feel is good. And we said, okay, let's do something which is something for the good of the internet. And then we sort of founded a part of the company which is called CZ.NIC Labs, and some of their products, you might probably know or at least use. What is CZ.NIC Labs? It's a R&D part of the company. As I said, it started as a small department of CZ.NIC Registry. Now this is the right opposite. We are a large R&D company, and there is a small registry attached to it. We do a lot of open source projects. The flagship and first project we have started is called BIRD. You might know it because it's used as a root server in more than 2/3 exchange point in the world, including those in London. So if you are appearing with a root server in your exchange point, it's probably BIRD. But there is more than that. We are doing, for example, authoritative DNS server, no DNS, or also it's sister project, not Resolver, and we also open source our registry, it's used by many African countries for run their own TLD, and we are also doing a lot of projects for example, disabled people with dyslexia, or people with some visual problems and stuff like that. So we are very active in open source, and actually everything we do is open source. And also we are doing a lot of projects for the local community. Probably just one interesting is CZ, which is the national security team of the Czech Republic. And we also host a lot of conferences, so maybe some of you were in Prague because of that, because we hosted the RIPE ITF meeting twice, ICANN meeting, and some other meetings. So that is about CZ.NIC. And now about Project Turris. So it started as a security project. Actually, it has a very nice name, Project of Shared Cyber Defense. And we wanted to address three main goals. First of all, we wanted to do some security research. We are running authoritative DNS, so we know a lot about things that starts on the internet, that spreads on the internet, because everything that starts with internet, starts with some DNS lookup. So, for example, if you analyze those data, you can see that some strong spam is spread, or some virus is spread, because if it starts to operate, you can see a lot of DNS queries. So we had a lot of details from that side, and we are also partnering quite heavily with the local exchange point in Prague, so we exchange a lot of data on that matter. But we realized we don't know anything about the security situation at the edges of the networks, what happened in people's homes, or how the situation looks like there. Another goal we wanted to address was to improve the situation with end-user security, because it's quite frustrating. The normal people, not like you guys, they don't know anything about the security. They don't know anything how to secure their networks, what to do with even home router they buy. So we wanted to help them. We wanted to give them something which will protect them. And last but not least, we realized that the situation with CPE devices, with Soho routers, is really frustrating. I think I don't have to explain it to you, but those devices have a lot of bugs. If you buy it, and you buy it for like $20 in a local store, you probably don't realize that this was manufactured somewhere in Southeast Asia. The software was probably sort of done before that. Then it probably didn't travel by plane to you, by business class. It probably went through a ship. Then it's stayed for a while in a local store and so on. So if you buy a brand new device in your store, the firmware there might be 6, even 12 months old, and that's quite a long time, especially in the security area. So it has a lot of bugs, a lot of problems. And if you even try to go to a vendor to find a new version of the firmware, you often see that there is nothing because you paid $20 for that, right? So that's the security problem, and also the other areas, for example, like IPv6 support, it's also frustrating. And again, I think you all understand what is this about. So what we decided to do, we decided to create a router. Let's say first we decided to make a software distribution that will address all those issues, that will collect some security data for us, that will help the people that will run this software, and also it will bring some additional value to those people. So we decided to make 1,000 of routers and give it for free, or technically for 1 Czech crown, which is roughly 3 pences, to give it to people and to collect those data and so on. We wanted to give them something which is powerful enough to forward 1 gigabit of traffic, 1 gigabit of traffic, and also doing the security analysis. We have a lot of mathematical models how to find some anomalies in data flows and stuff like that. So it has to be done online on the router. And since we couldn't find any hardware capable of this on the market, we decided to create our own home router. And that's how the router Turris started. We actually created 2 versions of it. First, 1.0, we created thousands of them, and we gave them to 1,000 households. It was in 2014. And next year, we created a new version called Turris 1.1. The main difference is just that 1.1 have a USB 3 port. And again, we give it almost for free to people's homes. So now we have like 2,000 of probes in people's home, and those probes collect a lot of data. What is the router about? It's quite powerful hardware. It's in a small box, but it's quite powerful. In its heart, there's dual-core PowerPC. It has 2 gigabytes of, I don't know what's the 2 gigabytes. 2 gigabytes of memory. It's pretty extensible. It has 2 mini PCI Express slots and USB ports, and so on. The main feature is that there is a automatically upgrading operating system, and we call it Turris OS, but it's just a fork of OpenWRT. And we really support it for a long time. So if you get that box home, you start with some version. We upgraded it quite often. We are adding features, new software, new features good for you, so you can use it. We had like 10 major releases. One thing which is probably which you might wonder, because sometimes if you do an upgrade, you need to reboot the stuff. So what happens with this device? It sends you an email. Hey guy, we need to reboot your device. We will do it in a week, or do it before by yourself. If you will not do it, we will reboot it. Between, for example, 2 or 3 in the morning, which is usually a time that people sleep. So I know you might be different, but you can set up your own time, for example, from 7 to 8, for example, after you finish all your maintenance work. So those upgrades, and then those security analysis, there are 3 main things. That anomaly detection I mentioned. Then we collect logs from all the firewalls. The device is set up very securely. There's firewall that blocks all the connections from outside world and so on. So we collect all the data from those firewalls and do a lot of analysis on those data. And also the device is, since it's capable enough, it can run as a honeypot. So it looks like vulnerable device, and again we connect data from those devices. End user who gets that device has an end user account on a portal. when you can log in and you can see what we collect from your router and some another additional information. And also there's, of course, simple end-user interface. We don't rely just on OpenWRT, Lucy. We have our own configuration device. It's for the really basic end users who don't know anything about network configuration. So it's simple wizard that leads you through the installation and doesn't allow you to set up it insecurely. So it enforces Wi-Fi passwords, strong administrator password and stuff like that. So you shouldn't be able, as a normal user, to set up it incorrectly. Of course, if you are a power user and you either connect using Lucy in OpenWRT, or of course you can even SSH to the device, then it's up to you. But with that wizard, it should be secure for the normal people. What data we collect? Of course, collecting data from such many devices, it's always a tricky thing. So that's why we have a crypto chip on the board. And there are some secure keys that that do the authentication and ensures that the collected data are correct. So we collect some encrypted information which contains security data, as I mentioned. We also do some network testing. So those devices also sometimes pings some VIP servers on the internet, so we can measure the performance of the network or if there is any outage and stuff like that. We do also some protocol-specific measurements, mainly related to DNS, for example. We measure if the ISP is not breaking DNS, if it's working well. And also it measures speed, so there's a passive measurement of speed, so it can show you how quickly you downloaded several stuff. And then we also collect some other logs like memory and flash utilization, load utilization of the devices, even the temperature and all the system logs. It's the first baby we created, so we wanted to be sure that it's doing well, and we wanted to have as much information as possible about it. Since this is not the main subject of the presentation, I will not continue talking widely about the project. I will just mention some of the highlights, some of the things we did, and we open source and now maybe part of, for example, OpenWRT. Collecting data is always a tricky. Everybody maybe, or you can be concerned about the privacy. What we collect and what data we know about you. So we set up a wall that we don't collect anything which happens in the LAN part of the device. But the live showed us that some people would like to know more about it. For example, when we said there is a lot of unsuccessful connection from your network, which means that there's probably some virus in your network. And then the end user asked, and which device is that? And we said, we don't know, because that's not part of our analysis. So we said, is there any way how I could know that there is something like that? So we created a software called Mayordomo. It's a simple daemon that analyzes data on the LAN network and stores locally on the router. It doesn't report to anywhere else to which IP addresses are the local devices communicating with, and then you see what is your device communicating to. It was also a reaction to some, I think, problems with LG smart TVs, which were reporting which channels are you watching, for example. So that's Mayordomo. We integrated it with OpenWRT. Again, it's open source, and this is an example, for example, how it might look. I think this is some of my Android devices. As you can see, is widely communicating with Google servers, and it's checking email. So you have such statistic about every device in your home network, so you can check to which service your device is communicating. I mentioned Honeypot. This is an example of my home router. It was in August last year. So as you can see, there are some people. So I had some visitors. And I have details of. I show a detail of one of them from Belgium. This guy wanted to give me some new software. That was very. I was very thankful for that. So, this is run on many of those devices, and we are collecting all those information. Actually, the Honeypot is not run directly on the device, but we run it as a service. So this the device just creates a tunnel to our servers. So actually, the visitor was not in my home, but he was visiting CZ.NIC offices, which he probably didn't know. And we are collecting those all those information, trying to analyze what interesting software are those guys trying to upload us, and we are trying to find some botnets and stuff like that. As a result, for example, we found a quite large botnet of ASUS routers. Surprisingly, they are not using SSH, but they're using Telnet. I didn't know that service is alive, but they're really using Telnet. They are just through Telnet trying to attack other devices, just trying to Telnet, trying some trivial but also not non-trivial passwords. So therefore, we know that they have some simple single center that distributes those non-trivial passwords, and it's about more than 30,000 devices. So it's quite interesting botnet. And if you imagine that they have single command and control, it can be quite strong when they start to attack, for example, some destination at one time. Some opposite that might be helpful to you from the analysis we do. We create we don't call it blacklist, but in reality it's a blacklist, but we call it gray list of suspicious addresses. So that's something you may want to import to your local firewall. We also publish, how many attacks are coming to various ports, response time of some of the internet servers we are looking at, and everything is on Turris.CZ. So if you want to see those data, just look there, and you can analyze them. Here's one example. For example, the data flows in my home. I actually pay for 60 megabits line, so it's quite strange that the maximum flow is 40 megabits. I have to talk to my ISP. But you can see in October 16th, I was probably downloading something because I utilized my line quite heavily. And this is the portent. So you can see we see like 800 attacks to FTP protocol a day. And last to this project, we, with cooperation with a local company which is doing mainly security alarms, we created sort of projects for the most active people. We call it Turris Gadgets. We gave those people some devices, some wireless devices, and the reason for this project was to find out what those creative guys will do with that. So they were, for example, doing heating in turtles' terrarium. They were, streaming sound to bathroom. They were streaming TVs and storing TVs and a lot of crazy stuff. It was quite funny projects, and we learned a lot about it. And it was one of the target of the project to show that the router, the device that is probably the only device that runs 24 hours in your home, except fridge, can be used for anything else than just routing. And when we presented this project, we saw a lot of demand. Two commercial companies were really involved in that. Somnos bought some of those devices, and Comcast supported the project. Thank you very much for that. And many people, when we presented the project, starting to show credit cards, and I want to buy it, and I had to tell them, no, it's not for sale. Sorry, it's just a security project inside Czech Republic. We cannot sell it to you. And we realized maybe there is a demand. Maybe there is a demand for open source hardware, open source software, CP device that will have some that will be good quality, have some be powerful, and so on. So we decided to start a new project to create. We call it Turris Lite, a new router that will be price optimized, cheaper than the previous one. And the idea was to make it open hardware and people could use it without any agreement and participation in the security project. We started making it, and later we realized that it's not probably light, it's more heavy, because we created something which is more powerful than the previous version, but it's definitely small, it's cheaper. So that's why we changed name from Lite to Turris Omnia. So here's the result. It's one of the most powerful Soho routers. It's able to forward 1 gigabit of traffic in quite small packets. It It provides like 450,000 kilopackets per second. It's completely open source hardware and software, and security research is optional, and it's a very flexible Linux-based router. This is the board. I will explain you all the details maybe later. So this is how the board looks like, and this is just a prototype of the box. You know, it's just a prototype. It's going to change a little bit, but just for you to see how big it is, I think you can agree with me. It's quite small, so it doesn't look bad. Inside there is a ARM-based Marvel Armada chip, dual core at 1.6 gigahertz frequency. It has 1 gigabyte of memory, definitely more than devices in this field, and optionally you can have 2 gigabytes. It has 4 gigabytes of eMMC flash and 8 megabytes of flash, NOR flash. That's just for U-boot. Here's the difference from the project. You know, those normal CPU devices has just 8 megabytes for the whole system, and we just allocate it for the booting actually. So that's the difference. And it has 6 gigabit ports. One is metallic and SFP. So it's you can either put a copper fiber or you can put some SFP module into that. And we have 2 lines between CPU and switch chip. I will rather show you this scheme. So the CPU, the circuit, has 3 interfaces, 3 gigabit interfaces. One goes directly as a 1 port is dedicated, and it can be either copper or SFP, and 2 goes to a switch chip that has 5 other LAN ports. So that's sort of network architecture inside the router. It has 2 USB 3 ports, so you can run some local home NAS server, whatever. It has capacity to add some other devices. It has 3 mini PCI Express slots. 1 is switchable to mSATA, so again you can put an SSD disk there. And 2 are planned to be allocated for Wi-Fi's, 5 and 2.4 gigahertz. There's also a SIM socket if you want to, for example, include a LTE modem into that, an LTE modem that doesn't have a SIM socket. There's a real-time clock chip, battery backup, again the cryptographic chip for better random numbering generation. You know, don't think about it just a router. It's more the server. So if you, for example, generate certificates, you need a lot of entropy. And there's a lot of expansion pin header inside, so it's ready for some play, especially if you know what those letters means. And most important part of the router, it has dimmable and programmable dimlets. It has 12 of them, you know, and if you have it at home, you realize that you cannot buy anything without 12 RGB dimmable LEDs. It's really important. Every router has to have it. And honestly, this is really enjoyed by the people that sleeps in the same room where the router is, because they can dim it just pressing one button. It's quite nice. It's one of the fastest Soho routers on the market. Here's some OpenWRT comparison. We are not the best in AS128, but this is due to the fact that we still didn't switch the acceleration on. So it's just the CPU throughput. And the last thing, you create some device and you don't know if there is a demand. And building such a device and production, thousands of them, is quite expensive. So we wanted to know if there is a demand for that. So we started an Indiegogo campaign last year. And we set a target of 100,000 US dollars, because if you are investing in Indiegogo, you don't know what are you buying, right? So you have to be a little bit entrepreneurial. You need to trust those people, and a lot of stories about the project that were unsuccessful, and so we said if there will be enough people who will collect 100,000 US dollars, there is probably demand on the normal market as well. And it was better than we projected. Those money were collected in less than a day, so in 21 hours. And when the campaign finished a few days ago, we collected 8 times or 8.5 times more. So it was really successful campaign. And we switch it to so-called in-demand mode. So currently there's $900,000 US collected. So it's really perfect. We like it. And if there's somebody here who backed this project, thank you very much for that. We are continuing to develop the project. As I said, this is a prototype, but we are close to finalize the production plans, and the production should start in April this year. And we will, since that time, we will send those boards. We will first, of course, send them to the backers of the campaign, and I'm afraid we cannot manufacture everything in April or May because we don't have such capacity. But anyway, it's going to be produced in most probably, for sure, European Union, most probably in the Czech Republic. So it will not be manufactured in Asia, and we really put the best quality parts into that. So we hope that's going to be one of the most fanciest routers in this field. Thank you very much.
Thank you, Ondrej. Any questions? Neil again.
Ondrej, it's a great project. I think there's two questions I've had. One is, why do you think no one's done this before?
I'm sorry, what?
Why do you think no one has done this before? And then my second question is, what's the kind of price point for the box? Roughly, is it 100 quid, is it 200 quid, or sorry, 120 euros, 125 euros? What is it? Okay, yeah, exactly. So I mean, this is the interesting thing is, if you build a box and thousands of geeks like us will buy it, will I see it in PC world is the question.
Yeah, both questions are perfect. Why nobody has done that before? There's not much companies like us, We are not for profit, and we want to help the industry. We want to help to educate people in networking, and there is not much other companies in the market doing that. So therefore, there is not much people who could really do that. Have money and have motivation to help, and have some time and support from the local community. So therefore us, and therefore nobody else. Although there are some, at least routers you can install OpenWRT, but I haven't heard about any router which is completely open hardware and such open in the way that ours is. And the second question, the price, it's a little bit higher than you would expect, but please keep in mind it's manufactured in European Union in very small batch. We are not talking about hundred thousands of boxes. So the price level of the complete box would be higher than $200 US roughly.
Okay, thank you.
Dave.
Hi, Ondrej. Actually, I wanted to ask you about something which you haven't mentioned, but I think is interesting for a lot of people in this community. I think at one point you were looking at developing a VDSL modem to go along with the router as well. Is that still something that is being worked on, or can you tell us anything about that?
Yes and no. Yeah, we have developed a small bridge, let's call it bridge. It was just a very simple device that just transfers anything from VDSL to Ethernet. There was a lot of demand, but unfortunately, when we created prototypes and started some tests, it wasn't as good as we expected. It wasn't as the DSL power wasn't perfect. The main problem is that it's quite problematic to buy 1,000 of chips of anything like DSL, DOCSIS, Wi-Fi. It's impossible. So we could buy some unknown chips somewhere from China, and the quality wasn't perfect. So that's why we didn't start the production. We still would like to do the same device, and we are discussing with one of the major manufacturers of chips that would be suitable for that. But their project starts in at least 100,000 pieces, so that's not easy for us. And we don't want to take a risk of creating 100,000 devices and then not selling them. So we are still working on it. We got some support from some other companies. We know that there is a demand in the market for that, because with such a device you would be free. You could put any router you want and connect it to DSL quite easily, either Turris Omnia or any of your favorite one, but it's really not easy to buy chips in such an amount.
Yeah, thank you. I think that is actually, for certainly the UK market, that is one of the most difficult problems to solve at the moment, is being able to put your own CPE on to a naked VDSL line.
Right.
Because none of those are open, and it's very difficult now to buy just a plain modem. So, yeah, thank you.